All right, now we're going to do procedure number 2 on, should be page 17 in your lab. And this one's a little bit different from the previous one we had done here. So we're going to design a circuit and draw a schematic for, in order to satisfy the following criteria. 1, we are going to have 3 momentary initiating devices, okay? The alarm circuit must remain energized once an initiating device is triggered. So that means we're going to keep that energized. The circuit requires 1 reset button that will silence the alarm. Your control circuit must operate no more than 30 volts. The alarm circuit will operate a 120 volt lamp and a 120 volt buzzer that we used in the previous one. This circuit must be tamper-proof in that cutting any wire, any control wiring to the initiating devices will automatically trigger the alarm. This circuit then will be designed so that if the power supply to the control circuit, the 24 volt, is lost, then the alarm will automatically be triggered. So this is the tricky part, where if we lose our 24 volt part of our circuit, automatically the 120 volt circuit will energize the light and sound the alarm. So we're not losing both of our circuits, we're only losing the control circuit. If somebody comes in and decides to cut a wire, for example, we want the alarm to activate. All right. What I'm going to do with regards to having our 3 initiating devices, I've decided that we're going to use 3 normally closed initiating devices. And for the reset, we are going to use a normally open initiating device or push button. And what we're going to do in our coil that's activating our alarm circuit, we're going to use a normally closed contact to control our circuit for the alarm. Okay. Previously we had a normally open contact. In this one, we're going to use a normally closed contact, and we're going to see how that works. We also have to think about our 3 initiating devices that I said are going to be normally closed push buttons. How are they going to be connected, in series or in parallel? And how is our normally open reset button going to be connected in reference to all that? And also, because when we want to initiate any one of the buttons, when I initiate and let go, I want the alarm to continue to sound. So we're going to use a holding contact to keep the coil energized, to keep current going through my initiating devices and keep my alarm activated. Okay, so what I'm going to do is I'm going to connect each one of my 3 initiating devices, my normally closed push buttons. I am going to connect them in series with each other. Then they will be connected to my normally open push button. My normally open push button will have a set of holding contacts in parallel with it. So we're going to use 1 armature for the holding contacts, and for my load, my 120 volt load, I'm going to use my other armature coming into the common number 8, but instead of using my normally open number 6, I'm going to use my normally closed contact to operate my alarm system. So we'll see how that works. So let's start again on the low voltage side of things. Let's start from our power supply. And I said that we are going to connect each one of our 3 initiating devices in series with each other. So I'm going to go into initiating device number 1. I'm going to come out of initiating button number 1 into initiating button number 2. So what will happen is if any one of these breaks contact, it will activate or deactivate my coil. Come out of initiating button number 2 into initiating button number 3. and then come out of initiating button number 3. Now I said I'm going to connect those 3 in series, then connect into my reset button. That's going to be my normally open contact, or sorry, push button. My normally open reset button here will be connected to my coil, position number 2. And then I'm going to complete the circuit from coil connection number 7 back to my supply. And now I need to put in my holding contact. Actually, let's use the blue ones for our holding contact here. I'm putting my holding contact in parallel with my reset button. So I said I was going to use terminals 1 and 3. So the one side of my, where I came into my reset button here, will be connected to my armature common number 1. And the other side of my reset button here, just so my holding contact's in parallel with it, will be connected to terminal number 3. So now my holding contact is only in parallel with my reset button. All right, so that should complete my low voltage side of things. And then we're going to go over to the 120 volt side. Again, we have 2 devices. I'm going to go for my power supply and feed my other armature, the common number 8, right there. And now what I said I was going to do, instead of coming out of the normally open contact, I'm going to come out of normally closed contact, which is position number 5. I'm going to then parallel feed each one of my 2 120 volt loads, my lamp and my buzzer, and then complete my circuitry with my identified from each one of my loads, like this, back to my supply. And that completes my 120 volt side. The way the circuit's going to work, basically what I need to do, once I energize my 24 volt side here and my 120, what will happen is my light will energize and my buzzer will sound as soon as I turn the power on. Then I will hit my reset button to silence the alarm. Now my alarm is ready to be activated. If I have an intruder that comes in, I'm going to mimic a window break or a door opening. So I have initiating button number 1, number 2, number 3. When I hit this one here, it should energize my light, sound off my buzzer. I can then, when I let go, it will stay in that position with because of my holding contacts. I will reset the button. I will try initiating button number 2. It should activate my light and my buzzer. I will reset. Then we'll go to initiating button number 3. Reset. And that should, every time I hit my reset button, it should silence my alarm. And the last component that they were looking for to be able to create is if somebody were to cut a wire. And what I will do is I will pull the wire that feeds from my 120 volt supply. Once my alarm is silenced, I'm going to mimic somebody coming in and cutting a wire. And in that case, we were looking to have the alarm activate. Okay? So like I said, the first thing that will happen once I send power to my 120 volt side and 24 volt side, my light will energize and my alarm will make noise, but I'm going to reset it and it's going to be waiting for something to happen at that point. Okay? Let's see if that's what we have. Okay, so that's what we had. All we did is we made the connection, we energized our circuit, and at that point our lamp and our buzzer activated because I used a normally closed contact on the 120 volt side. So it was normally closed. When I hit the reset button over here, it activated my relay. My normally closed contact then opened to de-energize this. Every time I hit my reset button, it's activating my relay coil, pulling in both armatures. My holding contact goes from normally open to a closed position to continue to have a path of current to my relay coil to keep it activated, to keep my holding contacts closed, and to keep my 120 volt side contact from being normally closed, to keep that open so we don't have our circuit energized. Okay, so let's try to check to see if each one of our 3 initiating devices actually work. I will try it first, reset it, second one, reset, third one, reset. Okay. And again, we wanted that whenever we hit one of our reset buttons, the circuit stays activated, my light is energized, and my buzzer is sounding up until the point where I hit the reset button.